Hey guys, what's up? I'm filming this video for you all because I've got some questions that I've seen on my comments, on the comments of my videos that are kind of on repeat. So I want to do a dedicated video for it and to answer it for you all. So I'm going to explain to you stuff, and I'm hoping it's going to be useful for some of you all. Yeah, let's go ahead. But before that, I'm going to say thanks to Skyfire for sponsoring this controller for my machine and also the laser head. Thank you, Skyfire. I'm going to put the address for the web here below. Also, you can use my discount code, which is going to give you 5% discount of all of the purchases on the website. So go ahead and use it. It's going to help me. Yeah, let's go ahead. Now I'm going to show you all how I can nest a sheet, and even if I don't cut the whole sheet, let's say I cut half a sheet because this is all I need, I can save the program. So even if I close the system and the day after, let's say I want to cut the other half of the sheet, I can still use it and put new parts in it, cut it. I don't waste any of the sheet. So here we go. I'm going to nest. I'm going to here, I'm going to part. I'm going to add my parts. Let's say I don't know what it is. Let's check what it is. Okay, I have this part. I want 50 pieces of it. And I have this another part, which I want another 50 pieces of it. And that's it basically. Now I'm going to nest it all on a sheet. I'm going to this play icon right here. Now I can change the sheet according to the size of my sheet. I will stay with those parameters. I have the length 2440 millimeters by width 1220 millimeters. The distance between the parts that I nest 4 millimeters. Let's do it. Now it's programming how to best put all the parts. Here it puts all my parts. You can see now the size of my sheet. The smaller rectangular shape, this is the size of my sheet. So as you can see, I have a lot of size left on my sheet. Let's say I already cut all of those parts. Now I have this one. This is my nesting results. This is the sheet that I currently have. I can click on it. I can save it, save as. Let's say I'm just going to call it 100 parts, 100 packs. Now I can close it basically. I can upload it again because I saved it. I can open it, put it back again, and here is my sheet. Now I can put more parts on it, and I'm going to show you how. Okay, so here I'm going to upload the nesting sheet that I already saved before. So here it is, all of my parts. I'm going to add more parts to it. Please notice that I'm not sure that this is the correct way. And I'm not going to lie to you all. I haven't really done it because I already cut full sheets, and yeah, so, but it is possible. I'm not sure that I can nest on it more parts, but I can add more parts. So I'm going to show you what I mean by that. And I want those. Okay, so I added those two parts right here. So if I want more of those, I can't really nest on it. I can array on it. So let me show you what I mean by that. I can mark them, and then I can click array right here. And now I can basically choose to add more. So let's say I want 5 rows and I don't know, 5 columns. This is the distance between the parts, 3 millimeter, which is fine, and click. So now you can see I added more parts. Now I'm going to show you some other cool features of the 2D cut ahead system, and it's going to be useful for cutting really thick plates. So I'm going to mark it, and then I'm going to go to ring cut. Now this is going to be useful when you cut in, as I said, thick plates. Let's say I have 2 kilowatt Raycus laser source, so like from 10 millimeter up, it's going to be really difficult to achieve really sharp corners. So yeah, this is what I suggest you all to do, which is, as I said, it's called ring cut. As you can see, it has this ring, and this is why it's called ring cut. And this how it doesn't actually disturb or deform the shape of the corner because the way of the movement is like this ring. So yeah, it's really useful. And as you can see here, you can change the parameters. We have another option for achieving sharp corners with thick plates, which is called cooling point. So I clicked on it, and now it allows me to choose when I want to put this cooling point. So cooling point, I can put it here, here, here. I can put it as well as on the line itself, but it's best to use, of course, on the corners, as well as inner corners, and so forth. So basically what it does, it's stop the laser, and you can decide the majority of the time that the laser actually stop work. So it stops, it gets to the corner, it stops for a few seconds, which is, you can decide how much time, and then it's going to continue with the cut. And again, on this point, it's going to stop, wait a few moments, and then continue. And what it does, basically, because the sheet, it really warms up because you're cutting really slowly, because it's thick metal. So the cutting result can really be, you can get a really bad cutting result if the sheet is really, it's too hot. And let's say if you cut in mild steel, which is you need to cut with oxygen, so oxygen really heat it up, and the quality of the cuts can actually be not good, and you can actually make it better with this feature. Now I want to show to you all a feature that is called Frog Leap. You can find this feature on CNC follower, and we have here open Leapfrog. The Leapfrog option, what it allows you to do, instead of waiting for the Z-axis to move all the way up, and only after that the Y and the X-axis will move to the desirable place, it allows you to move all the axes simultaneously. It moves all the axes in the same time, and it will allow you to save a lot of time if you are cutting a full sheet of metal. If you have like 10 holes in a small area, it will be a lot faster if you use this feature instead of not using this feature, obviously. Here we go, guys. This is 5mm mild steel. This is without Leapfrog. Let's take a look how it looks like. So this is what it looks like without Leapfrog. Now I'm going to show you how it looks like with the Frog Leap feature enabled. Here we go. Here we go. Now I know it didn't look like this much of a difference, but let me tell you, if you cut full sheet and you have a lot of holes or a lot of small features to cut, let's say if you're cutting signs or stuff like that, this is going to save you a lot of time on the machine, and it's going to keep you, overall, it's going to keep your machine working better and longer, because it will be less wear and tear of the machine, because it moves less. Now I want to show you the configuration software, or should I say softwares. This is a question that I've got a lot, like how do I configure all of the axes, because it also cut tubes and also cut sheets, and when I cut tubes, the gantry doesn't move, the rear chucks move backward and forward, so I want to answer that. So the AX3000T controller, which is my controller that I got from Skyfire, has basically two completely different configuration software. So I'm going to HMI folder, and now I have here pipe ahead and laser ahead. Now laser ahead, if I open it, I have here the 2D cut ahead software. So this is the software only for sheet cutting, and it has its own configuration software, which is called 2D cut ahead config. If I click on it, it will bring me to the configuration software only for the sheet cutting. And what it means, I won't be able to configure there anything about the rotary chucks or the Y3, which is what brings the rear chuck backward and forward. I won't have the configurations in this software for that. This software only has the configuration for the sheet cutting, basically axis, which is Y1, Y2 for the gantry, X-axis, Z-axis, and F-axis for the focusing head. I'm going to show you how to configure them in the 3D cut ahead software, because there in the 3D cut ahead software I actually configure also pulse and direction motors, and also EtherCAT motors, because as I said, my front and rear chucks access are by pulse and direction. So I'm going to go ahead in pipe ahead, and here I have the 3D cut ahead software, which is for only cutting sheets, and it has its own configuration software, which is called 3D cut ahead software. So I'm going to click on it. I opened the software, the configuration software, and this is how it looks like. Here on the side, I have all the EtherCAT configuration, all the EtherCAT connections. The controller, which is the EDS 3000 main I/O board, actually recognize all the connections by EtherCAT. So even if I don't use my gantry motors, which is Y1 and Y2, it actually shows them here because it recognizes the drivers because they are connected to the controller. So here you can see, which is the main I/O board. It is node 0, EDS 3000, below that node 1, Ray Tools EDS 2010, which is the expansion board, and below that I have 5 EtherCAT motors, which is Y1, Y2, Y3, X-axis, and Z-axis. And here you can see all the motors that I actually use here. I have Z-axis, which is node 6. I have it here. You can see it's Innovance EtherCAT. X-axis, node 5. Y-axis, node 2. U-axis, U2. U2-axis, node 0. Server port 1. And node 0, server port 2. So server port, if it shows you server port 1 or 2 or 3 or 4, it is connections by pulse and direction in the main I/O board. So node 0, all the node zeros, it is on the main I/O board, which is node 0 EDS 3000. And you can see also here I have the F-axis, which is the focusing head, which is also by pulse and direction. So if I want to choose different motors to configure them, I can go to X, Y, U axis, and here I can configure the motors. So this is for the X axis, servo axis, node 5. I can select here which motor I want to use for the X axis, the same for the Y, node 2, and the same for the rotary chucks axis, as you can see, and as you can see here. So as I said, in the main I/O board, which mine is EDS at 3000, we have 5 ports for pulse and direction drivers connections. If you want to use this controller and you want to have all the access by pulse and direction, you can't, because you don't have enough ports in the main I/O board with pulse and direction connections. So this is why I suggest to use only EtherCAT connections, because it's also easier. You don't have to solder anything. You just connect the Ethernet cable and it's done basically. But as you can do what I did, which use both. But I definitely suggest that you use only EtherCAT based drivers. So this is all the stuff that I got for you all. Hopefully you enjoyed it and you learned something on the way. And I will see you on the next one.